Hey, so welcome back, everyone. We're here once again. And as you can see, things are getting more interesting. We're getting there, we're getting there. It's not going to be easy, sure. Okay, let me see. In our last class, we implemented our token authentication, authorization, and then we moved over to data validation and security, where we discussed about data validation with Express Validator. That was a very sweet one, where we sanitized our user inputs, and then in case of any error or any empty input value, we customized our messages so our users will know, oh, this we're missing out, so I should just update my form input or do something more interesting, something like that. Okay, so today we're still on data validation and security, and then we're done with one. This is data validation with Express Validator. Today we will cover a whole lot of things: authentication and authorization principles, handling sensitive data, preventing cross-site scripting, XSS, and then rate limiting, secure headers with helmets, and then HTTPS, which is automatically handled by deployment servers. We won't be talking much about that because we already did in our NodeJs course, where we built our task manager with Node, where we discussed about HTTP secured and how it can be handled. Okay, so then last but not the least, error handling, which we've been doing. We've been handling errors in almost all of our projects. So what should we do? Let's check out. Here I've got, what is this? No. Okay. Sorry, 1 minute. So we have prepared something. We have these files, markdown files, have XSS, sensitive data, rate limiting, helmet. And let's check out authentication and authorization principles, which is here. And this should be inside of the source folder, like so. Move it. Okay, so I'm actually using Markdown here. Maybe most of us don't know what Markdown is. But I'm not going to be talking about that. You will make some research. Okay, what I will do now is you see, data validation and security. What is this? Oh, I combined the whole data validation and security. Okay, so we're in the data validation and security branch. So what I will do is I will simply push this code to GitHub. I think it will be easier to access it on GitHub and read it out than doing it here. Okay, so what I will do is something like data validation. And what's happening? What is this? Okay. Okay, so let's push our code to GitHub so we can access it. Okay, so let's check out our repo on GitHub. Let's go with GitHub. Okay, repositories. Then we have our KodeCamp. Okay, let's switch over to this very branch. Okay, data validation and security. And then we have open our task manager. And in here we have okay, in our source folder, we have our auth principles MD. Great. Yes. And we have, yes, here we can read it. And it's more clear here. Okay, so we're starting out with authentication and authorization principles. First of all, what is authentication? And authentication is the process of verifying the identity of a user, ensuring that they are who they claim to be. I said it in our previous class. And in Express.js, you can implement authentication using various strategies. And below are the key components and strategies. The middleware. We already know what a middleware is. Middleware functions play a crucial role in authentication. You can use middleware to check if a user is authenticated before allowing access to certain routes or resources. Popular middleware for authentication include Passport.js, but we won't be talking about Passport.js in this course entirely because before using Passport.js, you need to understand how things work under the hood. So when you go about implementing everything by yourself, you will get to understand that all those are just sugar to everything you've been doing. They're added sugar to it. So you can just go ahead and then do everything without with ease, with no stress. You understand? And then sessions. Sessions are often used to keep a user authenticated across multiple requests. Express.js can store session data typically in memory or using a database to keep track of a user state. And this is where the style comes in. Let's just look at our code briefly. Okay, so we have the route, not route, please. What is our index? Okay, index.js, something like this. Okay, so we have our session here. And instead of using in-memory session, we specified a store, which is a Mongo store, a database, a MongoDB database where we store our session. But if we remove this store, then our application will use the in-memory session store, which is not advisable to be used in production or production entirely. It's no good to use an in-memory session in production because it may cause memory leaks and then your data may not be safe. So it's good to specify a store where you store your session, and then on each request you get to know if your session is expired or not. So in this case, we specified our store to be a Mongo store, which we configured up here. The Mongo URL, the database URL, then the collection name is session. And if we open our database, we see the collection name to be session. And if there's any active user, we see his or her session there. And if we have 1,000 of active users, we see all their sessions there. And once the user is logged out, the session will be destroyed and it will be deleted in our database. And that is awesome. That's great. Okay. So next you have token-based authentication. This involves issuing tokens to users upon successful login. These tokens are typically JSON web tokens, also known as GWT, and are included in subsequent requests to authenticate the user. You can use libraries like JSON web token to handle JWTs. Okay. So the number fourth on the fourth item on the authentication is local authentication. This is the basic form of authentication where users provide their username and password. Express can handle this using form submissions and middleware to verify credentials. Exactly what we've been doing. So if you generally understand authentication, using middlewares like Passport won't be a problem. We first of all handled authentication locally, and then added some sugar to understand how everything is working under the hood. And then we added more and more sugar, validated our inputs, and then figured out how everything works under the hood and how to authorize users. And now let's look at authorization. Authorization defines what action a user is allowed to perform once they are authenticated. It controls access to specific resources or routes. And below is how you can implement authorization in Express.js. We've already done all of this, but then this is data validation and security. So we need to discuss how important all these are. So we're just discussing it, and you have access to this. You can go back to this anytime and check it out. But we just discuss it and then try to understand how important they are. So we have role-based access control. Assign roles to users, e.g. admin, regular user, and restrict access based on these roles. Middleware can check a user's role before allowing or denying access to certain routes. And this takes us back to our blog API that we're currently building. There is no access control. But after building it, we'll get to that maybe next week. There will be no promotional tasks. So what we will do is we'll give ourselves some work to implement the role-based access control where only the admin can be able to post. That is, if you have a blog system where you have different users, you have moderators, admins, and then they have access to your personal account. Give them access. If they registered, if the person is an admin, the person can be able to post, delete, and then edit blog post. But if the person is simply a moderator, you cannot delete or create, but then you can edit. Maybe try to edit the post and make it more eye-catching or something like that. And then permission, the second item on the list. In addition to roles, you can implement fine-grained access control by assigning specific permissions to users or roles. Middleware can then check if a user has the necessary permissions to perform a particular action. And exactly what we've been doing with our middleware. Got a lot of middlewares here. Token out. Let's just use this one, where we check if the user is logged in and there's a token associated with that very user. Then we will proceed to the next middleware with the user name and the user ID, where the user can then be able to use those to then make subsequent requests, like so in our controllers, in our task, and then we grab the here I am, and then we grab the ID and the username from the request user object. Then we make a request to get the user's task and only the tasks that are associated to the user. Because when the user was creating their tasks, they created it with with their user ID. They associated the task with their user ID. So only them can be able to get access to this user ID. And no one else but only them. Except you have access to their credentials, their username and password. You can log into their account and then you can be able to access their tasks. So you can, maybe you want to help them complete their task, their daily tasks or something like that. Okay, so that's it. And then middleware. As with authentication, middleware is crucial for handling authorization. Custom middlewares can be used to check if a user has the required permissions for a given route or resource. And we don't need to go around explaining all of this because we already discussed this and we're just looking at the theoretical aspect so we understand how this is related to authentication and authorization and all of that. And then the fourth item on the list, database integration. Often, authorization rules are stored in a database. When a user tries to access a resource, experts can query the database to determine whether access should be granted. And that's where our session, the session store, we assign a database to our session store so that we can store the user session in our database. And if the user is authenticated and the user is still active and the session is active, then they can query their database successfully to get their tasks and then work on them, modify them, or even delete them. Then the fifth item on authorization, error handling. This is what we've been doing in all of our tasks, on all of our classes. We've been handling errors and we made sure we handled errors from beginning to end. Like when a user is not authorized, you should handle this gracefully by returning the appropriate HTTP status code, like e.g. forbidden, and providing a clear error message. 403 is actually forbidden. So in this case, in creating a task, we'll have create task here. You can actually do something like if a user is not authenticated and he or she try to create a task, you return a forbidden kind of error message to them and the HTTP status code of 403, which is forbidden. And in our middleware, you can do something like unauthorized. If you don't want to let the user know they're unauthorized, you just let them know they are forbidden, like they're not allowed to access a particular route. It depends on your user case. You can tell them they're unauthorized or they're forbidden to access such route. That is, if they, for instance, you are a moderator and the admin, you are not the admin and you want to access the admin's route, you will get a forbidden kind of error message with a status code of 403 because you are forbidden to access that route because you are not an admin, just a moderator. Okay, so that's how important authentication and authorization principles are in developing web applications. And this, in our case, we are on the server side, and this is where everything works. The client side is just letting the user know what's happening behind, but everything, it's being abstracted. You only review the functionalities you want them to use today. All of this logic, all a user can see is a login form, a register form. They'll just impute their usernames and passwords and then submit. And then they get an error message or they'll be logged in, but they don't know what is happening behind the scene. So when you see some complex applications, you don't know the kind of logic it's going on in those kind of applications. But then if you get your hands on reverse engineering, you try to, once you see an application, you try to like, oh, this what this is doing, this what is, even though it's not actually what it's doing, but then you can try to re-implement that kind of application. You can rebuild it and then adding those functionalities to it. It's very, very kind of a simple thing if you are into reverse engineering. And I've been trying to figure it out. That's the reason why if I see any working application, I don't have to look at their code base. I just imagine, oh, this is what's happening behind the scene, this is what's happening. And then you go ahead and try to rebuild the application without looking at their source code. Okay, so next on our list, we'll have handling sensitive data. We're done with authentication and authorization principles, where we actually discussed about authentication and authorization principles. We discussed authentication, discussed middleware sessions, token-based authentication, then local authentication, which is the basic form of authentication. And then authorization, we talk about role-based access control, where you assign roles to users. Maybe in this case, you can come to, if you want to assign a role to a user, you can come to your Prisma, then your schema, and then you do something like, in the user model, you add a role of a string, and then you say at default, it should be a user actually, like so. And then later on, if they are signed in and you want to change a user to, let's say, a moderator or an admin, so they can access certain routes, you implement that functionality on your UI, where you click a button or submit their your email, and then automatically change their role to something like admin or anything at all, moderator or something like that. And there's a way you can do the, okay, actually we're using MongoDB, so let's see how we can even automate this. We can do something like enum, like so, and then you see row, and then inside of this row you see admin, moderator like this, and then user, or you can even say a mentor, like so. And then you can come down here, and then your row, you can see it's a row, then at default, you pass in your user like this. So that if a user try to supply anything apart from all of these values we have here, they will get an error. A row must be one of these: admin, moderator, mentor, or user. So if you want to change this, you can change it to a mentor, a moderator, or an admin, like so. So if a user is an admin, they can access the admin route and then create, delete, and post. If the user is a mentor, they can actually mentor students and access the mentor route. If the user is a moderator, they can go ahead and access the moderator route. So just how to use enums and all of that in our database using Prisma. Okay, so relationship matters. I guess we all understand the relationships here. Okay, but we're not discussing Prisma today. We're actually discussing data validation and security. Okay, so we move over to handling sensitive data. Handling sensitive data. Okay, let's get back to our repo, sensitivedata.md. Okay, so we have handling sensitive data. So we have some kind of principles we follow in ensuring our data is secured. If not, a hacker will get access to your data and then take down your application or get access to users' information, and then you'll be fined for that. It will take you to court and you have to pay because you built the application. So why didn't you then ensure the security of your application? So you are in for it. So in ensuring that our sensitive data is secured, Number one, we use environmental variables or environment variables, or I normally call it environmental variables. Use environment variables. So store sensitive information like API keys, database credentials, and other secrets in environment variables. ExpressJS can access these variables through the process env object. And this is not the Express thing. It's a Node thing. In fact, it's a computer thing. When you learn low-level networking, you learn about processes. And then when it comes to Node, they've added an env object to the process where these variables can be saved. You just go take a look at processes in computer in low-level networking a bit, and then get to understand a little bit of processes and how this env is being attached to their process object. So this keeps sensitive data separate from your code base and reduces the risk of accidental exposure. Sure, because when you push, like in our application here, we have our .env file with all of our, we have JWT lifetime, 7 days, secret, KodeCamp task manager, and then port 3000 and all of this. But then when you come to git ignore file, we've ensured that we don't push our node modules to the GitHub, our GitHub repo. We don't push our DS store, and then we don't push our environmental variables. So if we check our GitHub repo, we don't have any env file here. It's supposed to be in the root directory of our application, which is Express Task Manager. We don't have any env file. So if we push this to production, we have to go to the platform where we are deploying our app to set those environmental variables there. If not, our application will not be able to access them in production. So we have to go there and then set them there so as to be able to use them. Okay, so that's great. And yeah, Blessing, you can go ahead.
Thank you. I've always had this question with respect to environmental variables. Yes. Say, for example, I'm working for an organization. I worked on their code base, made some push, and set it up for production use. But after some times, probably I have reasons to either leave the project or leave the organization. How do I hand over the .env files for another person that will continue to work on that code base? You know, now at this point, the only place he could actually access is either he goes to that to the hosting site, or say, for example, Vessel now, there is a way you can access all the environment variables.
Yes, yes.
So, is there a way to properly hand over those files without breaching data security rule, either to the organization or to the team lead? Because I don't get that concept clearly.
There are many ways you can hand over those variables to the organization you're working with or you're working for. But let's say, okay, before you start working with any organization, probably they might have set up a production environment and a Git repo for that application. So that production environment, they will give you access to it. So when you decide to leave, they will deny you access to that repo and that environment. And before any organization will employ you, they're trusting you with their, let me say, should I say, the application you are building, the project you are working on, they are trusting you with the credentials you are using to, like the environmental variables, the variables you are using to work with that application. So in that case, when they deny you access, you won't get access to the application again and the variables again. But
I'm talking of some variables that I need to generate myself. Say, for example, now we're setting up a kind of login with email, probably through Google. Yeah. If I set up that that account, there are some keys that I need to copy and probably to be saved on the environmental variables section.
Yes.
So that file in itself, is there a way of probably sending it apart from pushing it to a private repo on GitHub?
Okay, from the little experience I've had so far, if you are working with any organization and you want to generate any credentials that requires an email or that kind of a thing, something like that, that requires an email, anything that requires an email, you have to use the organization official email that you are using to build that application. You have to use it to do that, to process that very thing. Like if you want to generate an authentication key for any API, like Google or anyone, you use the organization email to generate that so that you have access to it and it's their email. If you leave, they have nothing to lose. But any organization that, let's say you're working for a client that you have to use your own email, then you have to come to a conclusion with that very client. So I have this with my associated to my own email. So how are we going to do it? So you agree to it and then decide. If they say, okay, you can go with it, it should remain with your email. But then if we need it, we contact you and then you should take control over it. If we have any issues or we have any breach, we hold you responsible. You have to come to an agreement with that very client. But if you don't want that, you ask the client, I want to generate an API key for so API. So I need your email to generate it so that in case I hand over this project to you, you'll be able to maintain it without needing my help.
Okay, I think your point is clear. Thank you.
Yeah. Okay. So where are we? Environmental variables. I think we're done with this one. Yes. So actually, when we were deploying our server, we set some environmental variables and then we demonstrated everything. So we don't need to go over that again. We already know what environmental variables are and how we shouldn't expose them. Okay, how and why? All the same. So second item on the list is encryption. When storing sensitive data in databases, use encryption techniques. For instance, you can encrypt passwords using libraries like bcrypt before storing them in your databases. Ensure that you use strong encryption algorithms. Wow. Yes. Bcrypt uses some strong algorithms, some strong encryption algorithm behind the hood, behind the scene and under the hood. And we don't actually know what's happening. We don't know what the algorithms are. But then I think we should take a look. Okay, I think I need to show you something just for learning purposes. Let me show you something very quickly. Sorry, I have to show you this. Yes, this is what I want to show you. RSA factoring challenge. I want to show you this repo and then discuss some things. Okay, so in this repo, I said the RSA factoring challenge was a challenge put forward by RS Laboratories on March 18, 1991 to encourage research into computational number theory and the practical difficulty of factoring large integers into cracking RSA keys used in cryptography. So the mathematics behind this is the RSA laboratory state that for each RSA number, there exist prime numbers P and Q, so that Pn is equal to P times Q. So this is where encryption and then decryption comes in. So the origin of this starts with these ones here. Start with this RSA of 18. It's actually an algorithm for encryption and then decryption. We have symmetric encryption and then asymmetric encryption. I call it encryption because it's all the same thing. Symmetric, the key you use in encrypting a particular, let's say, particular value or credentials, a key you use in encrypting credentials is the same key you use in decrypting them. But then if you're using asymmetric encryption, you will use a public, let's say a private key to encrypt it, and then you send it together with your public key so that the person decrypting it will use your public key to decrypt it. Meanwhile, the public key it has a kind of knowledge about your secret key, your private key. So they'll go ahead and then do decrypt your data successfully with no problems. I think sorry, just this. I think we shouldn't be looking at this. Sorry about that. This is Python and we're learning JavaScript. So I just wanted to show you how decryption and encryption work with code, but then that is Python and this is JavaScript. You won't understand anything there. So let's just continue. So encryption, when storing sensitive data in databases, we use a library like bcrypt, or if you don't want to use bcrypt, we have two other libraries. But then you have to consider the time and memory these algorithms use. You know, designing algorithms, it's a kind of a complex thing. You have to manage resources, you have to optimize your functions very well. So if you're using recursion, you have to take caution so that your recursion will not recurse to your data goes down or waste a lot of resources. You understand? You avoid memory leaks. So encryption here simply means like changing your data in the form an ordinary user will not understand the content. Then decryption is changing that data in a human-like form where we humans will understand the content of the data or whatsoever. Is it data or information? It's still the same thing. Okay, so we have HTTPS, which is Hypertext Transfer Protocol Secured. So it's advisable to always use HTTPS to encrypt data in transit. Because when you send your data, let's assume we are chatting, and then you send your data you send a message from Lagos to where I am. And then in transit, a hacker can quickly grab that message and then decrypt it and then get access to what you're sending to me. If the information you're sending to me is sensitive, the user can and then use it to like get some valuable information about you and then harm you or do whatsoever he or she wants to do with it. But ExpressJS can be configured to use HTTPS by providing SSL or TLS certificates. This is crucial when handling sensitive data over the network. We actually discussed how SSL and TLS certificates work. In HTTP secured, when you make a request to your server will get the data you are looking for. It will encrypt it with its private key, and then it will send the data along with its public key. Then on the client, the public key will be used to decrypt that data, and then the client will get access to the raw information or data sent from the server. But if in case anything happens to that data in transit, when the data arrives to the client will make another request to the server saying, oh no, this data you sent has been tampered with. So give me a new instance of this data and then encrypt it again. So let's see if this will be tampered with as well. So the server will then make changes to that data, or it will dump that one, then create a new instance of that data, encrypt it, and then send it along with its public key for decryption. So that's the point of HTTPS. We have HTTPS, HTTP1, HTTP2, and all of that. So you go make some research and get to understand all of those very well. Then input validation. Sanitize and validate user inputs rigorously. Use libraries like Express Validator to ensure that data received from clients is valid and does not contain malicious content that could compromise your system. I think I don't need to talk much about Express Validator. We used it in our last class and we saw how awesome it was. You can use it to validate your data and then send back reasonable error messages and then status code to the client so they can know what they're missing out. and they can update their user input or their data or the request they're sending and all of that. That's sweet. And then login. Actually, we haven't gotten to login, but then we'll log sensitive operations and access attempts. However, make sure that logs themselves are adequately secured and not accessible by unauthorized users. Sure, maybe sometimes if you're logging requests, you want to save them in your database or send them to an API where you can easily access them. But we haven't gotten to this. We'll get to this in a class to come, in our next class or so. And the 8th item on the list is session management. If your applications use sessions, manage them securely, implement session timeout, and use secure cookies to store session data. Okay. How many points do we have here? Manage them securely, implement session timeouts, and session timeout and secure cookies. So let's check that out if we're following this principle. Session timeout. We've got a session timeout here. The max age is 60, 60, 24/7. 7 days. The maximum age, 7 days. And then is it yes, it is secured, but not in development. It is secured in production. You say environment variable is equal to application gets this variable, environment variable. If the environment you are working in, is it in production or in development? If it is in production, then set our cookie to secured. Set the secure property here to true. This will evaluate to true or false. If we're working in development, this will actually return, this false will be assigned to this variable env. But if we're working in production, if we push our application to production, and then this will evaluate to true and then assign the true value to this env variable, and then we bring it down here and set it to true in production. Then our cookie is set to true, and then it will be encrypted in transit to and fro and all of that till it is expired. And when it's expired, it will automatically log the user out, and then it will be deleted from our database, and a new cookie, a new session will be created with a new cookie, and then will be sent to the client to make subsequent requests. And that is sweet. Okay. We are following that principle right there. And then database security, secure database access, use strong passwords, limit database user privileges to what is necessary, and regularly update your database software. In this case, setting up database manually is beyond the scope of this course entirely. So we turn to use database cloud providers like MongoDB Atlas, or use local database like SQLite, which is not hostable in platforms that use serverless functions for hosting, like Vercel or Cyclic. They will not work because they need appropriate permissions to handle data in documents, and those are serverless functions. In every request, let's assume you are sending every function is to take a maximum request of 10. And if a function gets 10 requests, it will create another instance of that function. So those databases cannot be synced across those instances. If you have 10 instances of the same function in your application, there's no way those 10 instances can sync a single database. There's no way a single database can be synced across 10 instances of those serverless functions. So that's the reason why SQLite is not used in production, because it's a local database and you need to store it in the same environment where your application is working. But when you're working with database like MongoDB or MySQL, which is hosted in a different environment, you can just call the API, make some requests and all of that. So maybe if you don't understand serverless functions, you go learn about it and then learn how SQLite work and how it's not good for large-scale applications. And then Fly, I mentioned that in our task, fly.io uses SQLite in production because in that case, it doesn't use serverless functions, and then it manages your SQLite and then distributes it to different instances and then still syncs it for you. So that is specific to fly.io, but not other hosting platforms. This is up to you. You make some research and get to know that. And you get to know which database is secured, which is not. Maybe you learn how to work with other databases. Why I like SQL databases is because once you learn SQL, you will be able to work with MySQL, PostgreSQL, SQLite, and the rest. There's just a little syntax difference, but then if you get to work with all of these databases, you get to know which one is not to be used for. Like SQLite doesn't support enums, and you don't use enums in SQLite and all of that. So after learning SQL, you learn any of the NoSQL database, the document database like MongoDB, which is the most popular NoSQL database, and it's very, very good for large data. The reason why they keep saying MongoDB is only used for large data is because it can handle large data efficiently more than SQL database, because SQL data is stored in tables and then columns and rows. So you have to query this, query that, query, and join everything. But in document databases, fields are atomic, and then everything is well optimized. And it's a document, there's no table, so querying becomes easier. So if you don't understand what I'm talking about, you take a look at some documentation and then make some research. That's why you're a software engineer. Software engineer, you have to make research to understand some concepts better. Then we have regular updates. Keep your Express.js and other dependencies up to date. Security vulnerabilities are often patched in newer versions. And then I will learn how to use Snake to perform this function later on. But let me just do something like Snake so we can see what Snake is and how we can Snake. Yes. We later on use this. I use this in production because it gives me a weekly report of my applications in production and what package is vulnerable and which package I should update and which I shouldn't. So we have developer logged, security trusted, find and automatically fix vulnerabilities in your code, open source dependencies, containers, and IAC. That's infrastructure as code, powered by Snake. Snake's industry-leading security intelligence and deep code AI. Okay, so millions of developers build securely with Snake, AWS, Amazing Web Services, and then there's Google. We have Post, Manulife, Atlassian, Salesforce, and all of that. So when we get and look at all of these, Jenkins, JavaScript, secure your entire development cycle. So that is what Snake is used for. You integrate it in your GitHub repo, and then it gives you weekly report. And if there's any vulnerability in your repo, it will report it immediately, so you can update that and avoid XSS or any kind of insecure stuff. So number 11, we have regular updates. Keep your Express.js and other dependencies up to date. Security vulnerabilities are often patched in newer versions. Okay, we just discussed that. Number 11 is third-party services. If you use third-party services for sensitive operations, e.g. payment processing, ensure that these services are compliant with relevant security standard, e.g. PCI DSS, denial of service for payment processing. Okay, so I don't know much about payment services, but I know about Stripe, and I normally use Stripe in production and in development. So I advise everybody to use Stripe. If you go for anything else, I don't know. But all I would do is Stripe handle all of this. There's no denial of service for payment processing, so you use Stripe. And then we have 12, penetration testing. Consider conducting regular penetration testing and security audit to identify vulnerabilities and weaknesses in your application. And that is Snake does that. So later on, you learn how to use Snake to accomplish this as well. That's a very good one there. Then compliance. Depending on the nature of sensitive data you handle, you may need to comply with data protection regulation like GDPR or HIPAA, HIPAA. I call it HIPAA, or familiarize yourself with these requirements and ensure your application complies if necessary. Okay, so I picked out GDPR to explain, so we go and make research about HIPAA. So GDPR stands for General Data Protection Regulation. It is a comprehensive data protection and privacy regulation that was enforced in the European Union on May 25th, 2018. GDPR was designed to give individuals in the EU, in the European Union, greater control over their personal data, and then to harmonize data protection laws across the EU member states. So the key principles and then components of GDPR include data subject rights, DSR. GDPR grants individuals known as data subjects several rights over their personal data. This includes the right to access their data and right to have their data corrected, the right to have their data deleted, and then all of that. So you go ahead and then you read all of the consent, data protection, impact assessment, DPIS, and then notification of data breaches, data protection officers, DPOs, international data transfers, and then all of that, privacy by design. So GDPR promotes the concept of privacy by design, which means that data protection should be considered from the beginning when designing systems and processes. And that is where system design is very, 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 very important. System design ensures efficiency in your application, data protection, and all of that. So if you're building a complex application and you don't plan and you don't design your system, you're already a failure because you won't go anywhere with it. You will fail. You have to point out which database am I to use for authentication, which database am I to use for storing my data, and then which package am I to use for authentication. Okay, which back-end framework am I to use? Am I to use JavaScript? Am I to use Python? And why am I using JavaScript? Okay, why am I using Postgres? Why am I using MySQL? So should I use Redis? Why am I using Redis? Should I use Lighthouse? Why am I using Lighthouse? Okay, so you need to bring this all together, and then am I using events? Do I need to trigger an event whenever, to emit an event whenever that event is triggered? Or how should I do this? What should I do that? And all of that. Okay, should I use GitHub and APIs? I believe most of us don't know about GitHub API, but then I encourage us to learn about GitHub APIs. Learn about OctoKit. If you want to be storing data in GitHub or anything you want to be doing with GitHub API, you use OctoKit to accomplish that. I had a personal blog that I took down. I read it with Next.js, but I took it down and I'm rebuilding it with Remix. And I'll be done before the middle of next month. And then most of these concepts, I'll try to post it and then explain it very well on the blog and then send you links so you can go through it. And then I will try to explain it, to simplify it to make it simple as possible so you can go through it. Okay. And then all of that. I'm using GitHub to store my data. Anytime I create a post, it goes directly to my repo on GitHub. And then when a user tries to fetch it to read my post, when they visit my domain and then click on a post to read, it will fetch that data from GitHub and then return it to the user. The user will read it, but it's behaving as if I'm using a database. And then you use a database for authentication and all of that. So that is, we use Markdown for that. We store the posts in Markdown files and then read them in Markdown. Syntax highlighting, you make syntax highlighting easier and all of that. Okay. So I think that's all for handling sensitive data. We've discussed how you can use environmental variables, encryption, HTTPS, input validation, authentication, authorization, and then error handling, login, session management, database security, regular updates, third-party services, penetration testing, and then compliance. We also talk about GDPR. And that is awesome. So the next on our list is preventing cross-site scripting. To prevent cross-site scripting. Okay, it's another important one. So how can we how can we prevent XSS? Okay, so let's take a look at that. How we can prevent XSS. And in this case, let's have, okay, XSS MD. Great. Here we have XSS, cross-site scripting, known as XSS. Okay. So cross-site scripting is a common web security vulnerability that occurs when an application allows untrusted data to be included in a web page. In Express.js, like any web application framework, it's crucial to prevent XSS attacks. And below is how you can protect your Express application against XSS. Input validation and sanitization. This input validation is very, very important because a user may send a kind of a vulnerable code or vulnerable input to your application. And if you allow it in, it will cause some damage to your application, and then things may probably go wrong. So always validate user inputs. Ensure that all user inputs, including form submissions and URL parameters, are validated and then sanitized. You can use libraries like Express Validator to validate and sanitize input data. Okay, so use templating engines with auto escape. Okay, for this templating engines, I did not touch templating engines because we are not actually, our main focus here is Node.js and Express.js. Templating engines, you have to be a kind of a full stack developer to use this. Not really, but in a case where you want to build a full stack application without touching the client-side JavaScript, but you have to have the basic knowledge of HTML and CSS. So I decided to skip this one. Here it says choose a template engine that auto escapes. If you're using the templating engines that like Handlebars or EJS or POG, we have Handlebars, EJS, and POG. Those are the most popular ones. Make sure it automatically escapes user-generated content. This means that any user input, included in the HTML template, will be escaped by default, rendering any potential XSS attacks harmless. Okay, so the third item on the list is escape user-generated content manually. If you're not using an auto-escaping template engine when rendering user-generated content in your views, manually escape it. For example, EJS, you can use like this, user-generated content to render content without escaping, and then like this to render it with escaping. Notice the sign here. See the minus sign and the equal sign. Okay, the content security policy. Implement CSP headers. Implement content security policy headers in your Express application. CSP helps migrate XSS attack to specifying which sources of content are considered trusted. It can prevent inline scripts and other potential sources of malicious code. So you should go over this and read it. Avoid inline JavaScript. I talked about this in our previous class. We should avoid inline JavaScript. Your HTML, instead use external script files. Inline scripts are more vulnerable to XSS attacks. Even in not only your HTML files, you should avoid inline JavaScript. There are some values you have to have, like assign them to variables before using them in your code. You shouldn't just use them directly. Assign them to variables and then use them, and so on. Regularly update dependencies. If you notice GitHub, there's one package I use. It's sorry, I forgot it. But once there's a vulnerability in my application, it sends me an email. The package sends me an email that, oh, this is the vulnerability. Update this package or install this package and install another one also. And that is what Snake does as well. You can use Snake to achieve this. So most of you who don't know about Snake, don't worry. We are going somewhere. We learn the best DevOps practices, how to ensure coding style, and all of that. We're learning almost everything. Not everything, we can't learn everything, but at least we get ourselves where we can be comfortable to work in any team we find ourselves, and we can even act as a team lead because we'll be able to carry people along, plan our project, and then know what packages we need and why we need them. So we get there in a couple of these. So keep your Express and middleware packages up to date to benefit from security patches and updates. Yes, that's sweet. And then implement rate limiting. Implement rate limiting for API endpoints to prevent abuse and reduce the likelihood of malicious requests that could exploit XSS vulnerabilities. And then number 9, we have educate your team. Ensure that your development team is educated about XSS vulnerabilities and best practices for preventing them. Okay, so before I go ahead, let me tell you a short story about myself. I started out as a front-end developer. I was eager to learn programming, but then it was becoming tougher because I did not learn it the right way. Then later I began learning things the right way. And then I found out that as a front-end developer, I don't know how things work behind the scene. How is this being processed? I'm logging in. Yes, these APIs are developed. I don't know how they are developed. How are these APIs working? In fact, I should be a full stack developer. Let me jump to back end and understand this better. So I jumped to the back end and then started learning Node.js. I ignored Node.js because it was a kind of a complex for me. So I jumped straight to Express.js and then started learning. And that was how I found out that Node.js was very important. And I came back to Node.js and then I learned. But then if I find myself in a team, there were many things I needed to understand, like agile development processes, continuous integration and continuous deployment. And all of that, we have DevOps engineers. And DevOps is not even a job title. When you study DevOps very well, you will understand. So after this, when I became a full stack, I said, no, I still don't get what I'm looking for. How are all these automated? How is CI/CD, all these pipelines and everything? So I need to understand all of this. I jumped into DevOps and everything was becoming interesting, but also, in fact, I need to know everything. I need to know how these programming languages are being made and how everything works under the hood. So I was still in the process when ALX popped up and I said, wow, this is very interesting. I quickly applied for ALX and then luckily I'm going. We're doing it. And by God's grace, we'll graduate. But I advise everything you're doing, please try to understand how everything works under the hood. I never wanted myself to be a kind of a front-end developer. Why should I be? Anytime I find myself, I can act as a front-end developer, the back-end developer, or a DevOps engineer, or a team, anything at all. Or and just make sure you're good at what you do. Learn so that when you find yourself in a team where you find out you're a front-end developer and the back-end developer is developing some kind of whack APIs, you have to say, hey, this is not how this is done. This API endpoint has to be like this, and then these errors they have to be handled very well. And then you educate them. If you're the back-end developer and then you know, oh, so this front-end developer, they need to access this API like this. So let me do it like this. But one thing I tend to understand is, good, you will learn this and you will learn how to develop APIs, but then you will learn the rules, the bad practices and the good practices. But then at least you should just have an idea how all these work in the front end and how the front end developers use this, so that there are some cases you need to know, oh, this developer, in this case, our application works like this, and this developer will have to use this like this and this like this, so that you're able to make them efficient and then more easily to use for the front-end developers. Okay, that's a nice one. And then we have security audits. Periodically conduct security audits and testing, including vulnerability scanning and penetration testing to identify and address potential security issues, including XSS vulnerabilities. Okay, I think we'll be mentioning this a couple of times now, so we should get to understand this better. Monitor for attacks. Implement monitoring and logging to detect and respond to any potential XSS attacks in real time. Snake is there. We can add Snake in production and in development. But then for logging, we'll get to logging in a couple of these. And then installation of use and usage of XSS. And you may be wondering how this appears here as JavaScript, npm I Express SSS Sanitizer, Then you import XSS from Express XSS sanitizer, and then you give it a couple of tags to be ignored. Allowed tags, like you allow the HTML. This is used in the templating engines, but not in the. If you're building a server with no templating engine, and then you don't need to specify this, you just call your XSS. This likely refers to the third-party middleware named XSS. This middleware is designed to sanitize and filter user input to prevent XSS attacks. XSS attacks occur when malicious scripts are injected into web pages, and this middleware helps to prevent that by escaping or filtering potentially harmful content. Okay, so if you want to write any code, this here is Bash and this is JavaScript. So let me show you how this is done. So you will have XSS here. Let's scroll to the bottom and look at it. This is MPI, and then I can even come down here and then say for yarn users, that will do something like this. That will say bash. Then I will say yarn add express XSS sanitizer. At least we save it, and if I push it to GitHub, you will see that we have this kind of syntax, but then it will be yarn. After this one, we have another one before this. So this is JavaScript, and this is how we've written it in Markdown. This is known as Markdown. This is JavaScript and then XSS like this. And so I've added a Markdown support in my extensions here. You can install this extension so that you can easily highlight your Markdown. And then if you want to write inline code like this is to make this bold, but then this backticks it to make it an inline code. And let's see how it's working here. Look at it, it's actually an inline code and it's bold. Okay, so let's install XSS in our application and then use it and then apply it to our application we will know what the problems this XSS solves. So let's add it to our application, even though we're not using any templating engine, but then to filter incoming requests. It will do something like, okay, to make it easier, let's not type, let's just come here and then click this, then copy it. Then you come down here and then paste it in your terminal like so, and then hit enter. It shouldn't take much time. Wow, that's sweet. Then you come up here. I think it should be async error should be up here. Express session. Let's import it here. Import this from Express XSS sanitizer, and then you come here and say XSS, and then hit enter. Come down here. Then you want to apply this before any route so that any suspicious request coming in will be handled automatically by your app. So before this index route, you say app use XS like so. And it's asking for options. If you have any options, you can pass in, but we don't have any options. So we're going to be leaving it like this. So that's all for XSS. We'll know the importance. And if it's not clarify, if this importance, the importance of using XSS, if it's not clear to you, you can come back to this and read it and then make some extra research to get clarified here. And then this likely refers to the third-party middleware. And you should get to understand that every third-party module in Express.js is a middleware, because Express itself is a middleware, and without middleware, the framework is of no use. So just that we don't have time, I would have loved to teach you how to publish packages on the NPM, and then would have made a custom of this package. It's not that useful. This token out. Well, we just name it verify token, and then sorry, it should be in the middleware. And then you don't have to do this manually. Request and all of this. You need all those these user credentials that you need to verify, and then the JWT, you just pass them as parameters, and then this will be handled automatically. You don't need to write all this. You just call this function, verify token and then pass all the parameters and everything will be done automatically. But then we don't have time to publish npm packages, and that's not the reason why we're here. That's specifically for people who are building code for other developers, and I love that as well. As a developer or a software engineer, at least you have to know almost everything, if not everything. That's what I believe in. Okay, so we've learned about XSS and we've learned how to use it in our application. And then next on the list is what? Rate limiting. Okay, so what is rate limiting? Today we're not coding much. We're just talking and talking and talking. I hope we will get to understand all of these things because they're very, very important. Okay, so let's check out rate limiting. And the rate limiting here in our repo with rate limiting MD. Rate limiting MD. Okay. This is rate limiting MD, and we have some docs that are prepared for you. Actually took time to prepare this. And then if we come here, we have our rate limiting MD here, the file. And this is the markdown file. In case you want to see what's going on there, this is our bash for Yarn users, and then importance and configure whatsoever. And this is how I write it so that we can get a configured templates. And here we have everything written there appears as expected. Okay, so now we have rate limiting. Express rate limiting is a technique used to restrict the number of requests a client, and that client is usually identified by their internet protocol address, their IP address. So it's used to restrict the number of requests a client can make to an Express server within a specified time window. So rate limiting helps protect your server from abuse, DOS, denial of service attacks, and then ensure fair resource allocation amongst clients. It can be particularly useful when dealing with APIs or public-facing services. This is much like a HA proxy, a highly availability proxy, but it is not. It's just another middleware. But later on, we learn the importance of load balancers, layer 4, layer 7 HA proxies. There's the reverse proxies, because the forward proxy has to do with the client, the front end. We learn about the reverse proxies. Then we learn about virtual machines and containers. I want you to have the basic knowledge of all these things so that you can make research on your own. It's not, if you want to go in depth over everything we've been learning from day one, I bet you will have to take at least 2 years, 2 years with proper preparation and proper exercise, proper problem solving. If you want to go over everything in depth, yes, I should be, except you want to be learning 12 hours a day, then we can take like a year, because you wake up, you read non-stop for 12 hours or 10 hours or so. It can take us a year or so, but then it's not easy. As a software engineer, you are meant to solve problems. So, and then rate limiting helps protect your server from abuse, and we've read this. So we've understood how rate limiting is important to restrict the number of requests. So if you are sending requests, if you send 100 requests in 15 minutes, I want to say, hey, you are sending too many requests, bro. Stop and rest for a while. Like, come back in 10 minutes and continue sending requests. Why are you even sending these requests? You are just to read this and then do this and then go away. Why are you sending? Or you want to crash my server? No, stop first. Then you send them a message. You have to wait for 10 minutes and get back, or something like that. So here is how to implement rate limiting and Express an application. You install the required middleware. First, you will need to install a rate limiting middleware for Express.js. A popular choice is Express Rate Limit middleware. You can install it using npm or yarn. And the reason why we have to go with some packages because they're way optimized. And then we'll look at this later, how to make choices of third-party modules to use in your application. So because they're way optimized and then they're way tested, and then I love testing. We'll talk about testing later. We'll start from scratch, and we even try to write our own library for our testing library. We'll understand in depth how everything is working. Then, boom, we get there. And I tell you, we love it because any application in production without testing is not. In fact, it's not 50% working the way it's supposed to. Because when you get to run some unit tests and then integration tests on that application, you get to understand that, oh, I made some couple of mistakes and I should have tested this. Then we learn TDD, test development, where you have to write tests, and then you first of all write your test, then make sure they fail, and then write code, and then make sure the test pass, and then you refactor your code and then make sure they meet to your required standard. Wow, we have a lot to do. But after this course, you will become an express guru. Believe me. In fact, let's continue. So what we have here is we install our required middleware, npm install express rate limiter. And then for Yarn users, if you are using Yarn, so Yarn add express rate limit. I don't use Yarn. I use npm for reasons best known to me. I discussed that earlier that for npm and that, in fact, npm is the best. If you want to check out, compare two of them, read some docs, and then make some research, you get to understand. That will take you up to an hour or so. Okay, so then after that, you import and configure the middleware. In your Express.js application, import the Express rate limit middleware and then configure it with your desired options. For example, I tried to do something like this. Import Express from Express, import rate limit from this, and then create a rate limit with desired options. You create an app instance on Express, and then you say rate limit is equal to, the limiter is equal to rate limit, Windows in milliseconds. Windows in milliseconds, this is equal to 15 minutes. So the maximum request a user can make in 15 minutes is 100. So this will be tracked by their IP address. Limit each IP to 100 requests per window millisecond. So if this user, if a specific user makes 100 requests in 15 minutes, you send them a message, too many requests from this IP, please try it later. Please try it later. Don't take down my server, please. And then you say, down here, you apply the rate limiter to all routes or specific routes. Then if you want to apply to a specific route, you come here and then you say, app gets, this is app gets rate limit route. And then limit, then you pass in your limiter because it's a middleware. Then you pass it in here before this route. Then this is the same thing as doing something like this. Don't get confused. The same thing as doing something like where's our route task. You do something like this, you just pass your limiter here. If you want it to be applied to only this specific route here, this specific router, you just pass it in here like this, and then it will only be applied here and not here. Okay, so that's a good one. But in this case, we want it to be applied to the whole of our application. Okay, if you don't want this request to be applied to people who are actually using your website for, or your web app for something that they may make more than 100 requests per 15 minutes, but then you are building microservices and you want a part of your application to be well maintained, and then you don't want user to make more than 100 requests, then you can apply that to that specific, and then we will get to microservices in a minute, and then we'll see how useful microservices are and how hard or easy to maintain them are. Everything has an advantage and disadvantage. Then you consider the disadvantages and the advantage, and then you make your choice. And this type of application we built is a monolithic application, because this is not a microservice application, because everything is command, and if one thing breaks, the other doesn't work. In the sense that if your authentication is working and then you fail to fetch some tasks, what is the use of the application? You are authenticated and then you cannot get access to your tasks. It's going down, and then that will even cause your application to fail. And then if you come down here and then the index file of this application is down, your authentication will be down, authentication service will be down, and then your task service will also go down. But in a case where it's a microservice where the tasks have their own service and the notification has its own service, if the task service is down, your authentication service is still working. Users can actually get access to your application, log in, authenticate, but then cannot access anything because your task is down. You can even make it in a way where if a user creates a task and then the get task route is down, they can also create a task, but they cannot, all of that. We'll get to that. Okay, so use the middleware in your routes. Once you create, you can apply them, customize error responses. You can customize the error response sent to client to exceed the rate limit by providing the message option when configuring the rate limiter. This message will be included in the response when the limit is exceeded. This message will be included in the response when the limit is exceeded. You should get to understand this one. So everything is wired under behind the scene. Now we don't know how it's wired. Maybe if once they exceed this, then they will add this to the response object and then send it back to the user. We already know how the responses work, and those are objects, so easy to customize. Okay, so sweet. So rate limiting in conclusion, rate limiting is an essential security measure to protect your server from abuse, but it should be configured carefully to balance security and user experience. Just adjust the window MS time, that is the time window, and then the maximum request value to suit your application needs, and then and expected traffic patterns. So what is here is, let's say you have an application where, what application is exactly? Did they make much requests? Okay. For instance, let's say you have a chat application and then you remit a user of 100 requests in 15 minutes. When you're chatting, you're sending messages. So you send one message, one request, send another message, another request, you send an emoji, another request. So just count how many messages, if you are fast and the person you're chatting is fast. Just imagine how many requests you make in 1 minute or 2 minutes or 10 minutes. Talk more of 15 minutes. So you make more than 100 requests in 15 minutes. And then when you get to 100 requests in less than 15 minutes, you will be sent this message and you say, wow, this service, this platform is not good enough. And that's a very bad user experience. So you have to go, oh, I don't like this. Let me go look for like Facebook or Twitter or WhatsApp where I can chat with my peeps and then leave this, because this, how can I send 100 requests? So you have to, and then maybe take this out of that route, the message route, and then take it to another route. You don't want, or you can send it 1,000 requests per 15 minutes, because I think that it's not even possible for a user to make 1,000 requests in 15 minutes, even if you are chatting or something like that. Or you can make it 500 or 200 or so. It depends on your use case. Okay, so let's try to set this up in our application. In this case, this is tasks, and user will be creating and deleting tasks. We just stick with this 15 minutes, 100 requests, because if you try to delete tasks and then make those bunch of requests, maybe our server is not as strong as you expect. So if you try to make those requests frequently, 100 requests in 15 minutes, then we'll say, oh, wait, you need to stop. Maybe you come back later and continue. Okay, so what do we have here? Just copy this, boom, and then come to our editor here, and then paste this, and then hit enter. Shouldn't take much time. Okay, installed already. As you can see, everything we have found 0 vulnerabilities. So application, there's no vulnerability in application, and I'm happy about that. We have a happy face. Okay, so now we import rate limit from express rate limits. Okay, let's import it immediately after XSS, because first, immediately you start your application, or let's say you host your application, the first thing the user will do is send a request. So you want to import this first so that you handle you sanitize the input and then handle if there's any suspicious request. And then after that, you continue sending requests, and then you want to limit it. So you say import rate limit from, is it express rate limit? Yes, it is. Then you come here after this configuration and after these environmental variables, and then I think it should be after this one. You see const limiter is equal to rate limit. Then create an instance of IP rate limiting middleware for Express. The middleware that rate limit clients based on your configuration. Okay, giving an object. Then we come back here. See, we have a window MS, max, and then message. Okay, so what we will do is have window MS of 15. Should we make it okay, 60 and 1000 as in milliseconds. 1000 milliseconds times 60. That is a kind of 60 seconds. Is it 60 seconds? So 60 seconds times 15 times. That's 15 minutes. So we've got our 15 minutes right there. Okay. So we have our max 100 requests and then message. You see max 100 and then message. You can see too many requests and check back in 5 minutes. Too many requests, check back in 5 minutes. Like this. Just leave it like this. Like so. Too many requests, check back in 5 minutes. And then after this, app. This is an application level middleware. You want to make it an application level middleware, or if you don't want, you can make it a router level middleware where you can come to your router here. And then you can just ship it in somewhere here before any route also. That's it. But I want to make it an application level middleware, then you say app use limiter, like so. And we are good to go. Okay. So I think that is just how to use the rate limit, express rate limit. But this is for a monolithic application where you are not using any HA proxy or any reverse proxy or any load balancer or a firewall. You basically use this. At least it is very, very simple to implement. Not less than 5 minutes, you're done. But when you want to use load balancers, that is for a kind of a complex application where you, if you want to use a layer 7, you redirect authentication to a specific server, and then you redirect your tasks, requests concerning tasks to a specific server. But if you're using layer 4, then you have to redirect that using the IP address as this rest limit is doing here, or you use some kind of mechanism. We'll learn about layer 4 and 7 later. I think we're done with this. And then let's start our application and make sure it's working as expected before we break it without knowing. npm run dev. And then I think it is, we don't get a cabloy. Whoa, it's running, no cabloy. So that's good. Okay, and then let's see how many packages we got. And I told you, you should be serious with this application because we're going to be using it to the end. We'll create microservices with it, load balancers, everything with it. So sure be serious with it. Then later when we start testing, we change this command here to the command for our test, so that when we run npm run test, then our test will run. That's sweet. So the development dependencies, we have node 1, then the dependencies we have, oh, this is sweet. And then we'll be having a lot more because we're here to configure our application to the standard we want. And this is just a basic application so far. Okay. So let's stop our server and then return to our business. Okay, so let's go back to alpha. I think we're done with rate limiting. And then we should look at secure headers with helmet. Helmet. Is it helmet where to protect our head? That's where the word is coming from. Okay, let's see how we can then use helmet in our application. helmet MD. Okay, so we have helmet here. Well, securing your Express.js application by setting secure HTTP headers is a crucial part of web application security. So the helmet package is a popular middleware for Express.js that helps you easily implement these secure headers. And here's how to use helmet to set secure headers in your Express.js application. So we just say install. Well, first of all, install the helmet package. If you're using npm, if you're using yarn, it's up to you the kind of package you're using. Then we import the Express and then the helmet, and then we make use of it. Okay, so let's come down here and see. By calling app use helmet, you enable the default set of secure headers provided by helmet. And then customize helmet middleware. While the default setting provided by helmets are generally secure, you can customize the middleware to enable or disable specific headers based on your application's requirements. There's default source and then script source. And this is okay. In this example, we've enabled the content security policy feature and then provided custom directives. This allows you to specify trusted sources for scripts, styles, images, and other resources, helping to prevent XSS attacks. So the helmet middleware simplifies the process of adding secure HTTP headers to your Express application and enhancing its security against common web vulnerabilities. So it's a good practice to use helmets along with other security measures to enable the safety of your web application and its users. Okay, so let's go ahead and then use helmet and then content security policy here. Then we've got directive, default source, self. The default source is the source of the application. Then the script source, self, and then trusted CDN, where your scripts are coming from. Because when immediately you enable this, you cannot load script outside of this the domain, the CDN domain that you are inputting here. Okay, you say you are loading your script from Cloudinary, or forgetting the CDNs. Oh my god. Okay, let's say you are loading your scripts from 3 different CDNs, and then you include one of the CDNs domain here. You cannot be able to load scripts from those 2 CDNs because you've specified this to be the trusted domain. And then those other ones are not trusted. So when you try to make that request, the application will deny you from making a get or post request to those CDN domains. So you have to include all of them here. Then where you're loading image, if you have any image you are loading, you have to include the CDN hosting the image or the video or all of that. You have to include it to make your application safer. And if you've worked with Next.js before, this is the kind of thing Next.js does. You cannot load images in Next.js except you go down to their next config.js and then specify the domains where you're loading the images from, so that they can know, oh, this image is coming from this CDN, this is coming from this CDN, and any other one you've not specified, it will throw an error. Then no, this is coming from an untrusted source, so we cannot allow it in your application. So you have to go and make some changes. Okay, so let's see how we can do this. npm install helmet, copy this, come down here, and then paste it, npm install helmet. That's fast. And then let's go back and see. Okay, after installing the helmet, we import helmet from helmet, and then we use our helmet. Since it's the helmet, and we're using it with XSS rate limit, I think the helmet should come first. Import helmets from helmet. And then you come down here and then you see app. Since it's a protection measure, and you know, before, if you are protecting your head from injuries when riding a bike, first of all, you cover your helmet before you start your bike. So we apply this middleware before any other middleware. See, app use helmet, like so. If you have handlers, you can pass in your handlers as has been specified. Then let's come down here. It's actually a function, so we have to call it to say secure HTTP headers, and then we can pass this and it. Are we using any images or any trusted script? So we don't need this, but just for reference purposes, you can then, anytime you need to specify some secure domains in your app that you are used to, like third-party services. This is why you are using Google APIs or AWS, or you are using Amazon S3 storage as your database, or you're storing objects there, or using MongoDB. You can just come. Oh, okay, that's great. We're using MongoDB, so we can just copy the. It's actually not a script. Now we're not even using that in trusted. That is not a script. So add another directive and then add it, but we don't have to add that now. It's as simple as that. Okay, so let's just call this. How bad? Like so, options. You come here, clear our terminal. Let's start applications. Be sure it's running npm run dev. Okay, so it's working. And now we're gradually moving our application to production. Now we can push up and allow users to use it in production. And you know what? After this API will be open source, and then you can actually use it or find a front-end developer that can develop a front-end application for users to create and manage their tasks. And then you can go ahead and then create a pull request, of which I will approve, and then you can add some kind of a password and email authentication, and then add notification services that if a user's task is getting to it, the user is supposed to do this as a task today, and then the time is running up, you will send a notification to that, hey, you've got a pending task that you need to complete before today runs out. Okay, and that will be a good thing. So we can use it to practice, we need to pray, to collaborate, create pull requests, and I'll be waiting for that. Okay, so let's stop our server. And then what else do we have on our list here? Rate limiting secure headers, and then we have HTTPS. And this is handled by our deployment servers. And when we start working with servers, you know what? We touch this in our subsequent classes, but not today. We touch HTTPS, and it is very, very important because when you're building a server, you want your content to be secured. You want, when a client make a request to your server, you want to send the content in a secured mode. In development, what we're actually doing here is everything here is not secured. But the reason why this is good, because this is not global, it's local. It's a local IP address, and then we're using Postman to just test it. But once we push to production, and this becomes secure because the HTTP here we're using becomes HTTPS, it's automatic, and it becomes secured. Then that becomes very, very sweet. Okay, so I think I should let's move this up to make our file more readable, and then let's move it to this place, like this. All these application level middlewares. So let's grab this and then place it over here. And come here, leave a single space. But before that, cut this and then bring it up here. Paste it like this. Yes. The reason why this is before this index route is because we want to sanitize user input. Even if it's a GET request, we want to sanitize it before you can get access to these index routes. And then after that, we have our session, our token out, and our tasks. Then we'll have the last one, say the error handler, and then the note found. Can you see how we've arranged this? that if you move this error handler up here, and then later on an error occurs, then there will be no middleware to handle the error. Then your app will go kabri, will go, and then everything will go. Okay, so you have to know which middleware and which middleware to use first before you arrange them accordingly, like so. And that also applies to this, please. In this case, this cannot come before this. This must come before this, like login auth validation register must come before the validate auth. But if you place this before this one, then nothing. I think you are just wasting your time. It's the same thing as placing the mirror out before this one, because you have to verify the token before passing it to the mirror out. So if you place it here, you need to pass the mirror before getting to the token out. So you need to know where to place your middleware. I think that is sweet. I think we will have to push our app to production. So git add everything. So git commit messages, feature add rates limit and XSS, like so. And we'll say git push. Okay, so we've pushed our work to GitHub. Okay, so now we'll come back. What next do we have on our list? We have error handling. I don't need to talk about this. We've wasted a whole lot of time handling errors in our application. And here, we've even created a custom error API that can effectively handle errors for us. And then this message, I think we don't even need to do something like this. We just need to remove this, and our code will still work as expected, because the message is coming from this error object, and then we are initiating it using this super keyword. We get a property from the parent object that we're inheriting from. We simply initialize it using this. We call it in our present custom error API here. And then the status code is not coming from the error object, so we just set it here and then export our listing. And then we used it in our not async wrapper, in our error handler, like so. If there is instance of this, we do this and we do that. So error handling is very, very important. And you've seen the patterns we've used to handle errors to ensure every error returns a meaningful error message to a user. So because if at all the error being returned is not an instance of the custom error API, which itself is inherited from the built-in error object, then we don't know what the error is. That possibly may be coming from the server. That means the server is having a problem that we don't know. So we just send internet server error. But we hardly encounter this kind of errors because we've handled our application. And then if a user should send this, it's in development that we'll be getting this kind of errors when developing our applications, because when we make a mistake or a route goes down, our application goes down, we try to make a request, we get this error. But in production, this is not this internal server error. I don't think it will, except your server is down. If your server is down and the user tries to make a request, then they will get an internal server error. In fact, the request will not even go through, but it depends on how your server is working. If it's down in some parts and then some parts are working, you can get this message, the internal server error. Okay. Then in our session out, we handled everything. This our session out middleware, where we make sure we verify the user and then add the request. We assign the request user to this request session user to this request user object, and then pass it over to the next middleware. And then the task validator, we use the express validator here, and then we avoided writing inline JavaScript. We assigned the values to these variables and then we pass them here. so that anything we want to change, we can change it to 5, and then we don't need to come down and write it here, write it and write it here. No, we can just do it once, and then we make sure we validated the ID params coming from the get task validation register. We will make sure it is an ID and it is required. If you want to get a task without passing an ID, you get ID is required to get a task. Okay, that's sweet. And then instead of manually converting our completed to a Boolean, we convert it to a Boolean here. And then we can just go back and then remove that. But for security reasons, we should leave it like that. And then we write a validate task function here that will validate our inputs and all of that. So this is for error handling and the input sanitization. So you should take this into consideration and make sure you handle errors very well, and then you do what is expected of you. If not, your application, this is a server, this is not client side. And you know how hackers work. And we have not even done anything to protect the application, because a hacker can easily hack our application. There are many, many ways we can do this, and that is where load balancers and HA proxies and the IP addresses. If your IP address is suspicious, you'll be denied. You'll be denied of your service, and that is very, very sweet. Very, very good. I think we're done with data validation and security. We've discussed all the security measures we need to take and how to validate our data. Though there are other things out there like proxies and then load balancers, how to reduce to distribute the load of our server to different servers. But then we will get to that in a minute. But I think we are done with this. And then error handling, we don't need to talk about it. We've been doing it, and we even went to some extent with it. So in review, we've learned data validation and security, and that is awesome. That's very, very sweet. And let me just, oh my God. Should I tell you about this? No, just look at it, and then we call it a day. And then I will see you next week, and things are becoming more interesting. Just keep researching, don't give up, buckle up, and make sure, my God, it's becoming more interesting. Any other questions? Even though I've not received any questions from anybody. If you have any questions, you can go ahead and ask. If no questions, we call it a day and a week. And then we'll see again on Tuesday next week, 11 a.m. Thank you. Until then, thank you.